Hello, my name is Chang from SS Lab of Postech, and I would like to present Sensor Chain, a lightweight scalable blockchain framework for Internet of Things. And here are the table of contents. I just start from the introduction and motivation, and then I would like to explain the design of Sensor Chain framework with four different approaches that the paper suggested. And I would like to conclude this presentation with my review toward this paper. And here is the introduction. Uh, the interest on Internet of Things increases over the past several years. So here is the figure of the naive IoT structure. Every single things such as car, door, clock, TV, and refrigerator uh, is connected to wireless sensor networks via the sensor attached to each things. So IoT connect physical infrastructures with machine intelligence, information and communication technologies based on sensors attached to things and wireless sensor networks, which is abbreviated to WSN. So here is the current IoT system, which is centralized IoT system. As the mobile IoT systems generate an enormous volume of variety dynamic context data, the ordinary current IoT system's limitation is widely open to every researchers related to IoT. So this centralized IoT system faces with several problems. The figure shows that each things uh, are all connected to the centralized service provider server. So if this service provider server has any limitation or any problem, then both manufacturer and customer has problem. In the perspective of manufacturer, the manufacturer has high maintenance cost and software update issue because uh, everything's are just connected to the service provider server. So the burden the server has is really high, and also in the perspective of customer, it has just phoning home issue. It means that each thing has the lack of trust of other devices. For example, in the case of car, it cannot trust door, clock, TV, refrigerator because it is just um, communicated via service provider server, so it cannot believe the information of other untrusted devices in this centralized IoT system. So to recover this limitation in centralized IoT system, researchers just suggest new alternative IoT system with blockchain. Just assume blockchain applied in pure P2P mesh network. I do not draw the line, every line in this mesh network. However, just assume blockchain applied in pure P2P mesh network. Then it is kind of a distributed P2P way of recording digital interactions. So in this case, every single network linking is represented in this part. So no more limitations in centralized IoT system comes out in this version because every single things share the same chain data of the transactions, so there will be no burden in service provider server, and also in the viewpoint of the customer, each thing can believe each untrusted things via the consensus mechanism in this IoT with blockchain framework. However, still there would be some problems in structure of IoT with blockchain. In other words, IoT with blockchain has also limitations. The first thing is, what if time goes by? Uh, each IoT node requires more and more resources to manage them in their local spaces. Because if time goes by, the chain data with transactions would be exploded, because time is infinite, so chain data would be growing infinitely, so it would be big problem because each node cannot maintain this infinite chain data in their own node. So this would be one problem of the IoT blockchain. And the next one is, what if number of blockchain nodes increases? This is also a problem because the block size would be really big, because there would be many transactions among all of the blockchain nodes. In maximum, the transaction number per time would be n times n minus 1 divided by 2 if the node number is n. So by the node number increases, the scalability issue would be occurred in this part. So both would be the problem. What if time goes by infinitely? And the second problem is, what if number of blockchain nodes increases? Both problems just gathers into the scalability issue, especially in mobile related scenario. Computing power and battery in edge device would be constrained in this mobile related scenario, and increased size of chain data is burden for edge IoT blockchain nodes. So this is the motivation of sensor chain. So the authors suggest a sensor chain in mobile related scenarios where a mobile node is not necessarily required to have a global view of a blockchain. For example, environmental monitoring mobile crowd sensing application is the case of this scenario. So sensor chain just divides global blockchain into smaller local blockchains, as you see in this figure, in spatial domains. So in spatial domain, each blockchain node maintains each local blockchain, not the global blockchain in their node. And also they limit their size through a temporal constraint which is related to the time. So this is newly added in this sensor chain. And here is the system model and important assumptions. When this sensor chain just assumes permissioned blockchain, and this is divided into cells. So as you see in this picture, this region is divided into several cells, and each node can perform lightweight aggregate operations such as max, mean, or minimum value, and the weighted average. So each node can perform only lightweight aggregate operations, and each node can have a role as mobile node or static node. Static node just don't move in the region, but mobile nodes moves toward the region. So this mobile node can passes from cell 1 to cell 2. So this mobile node is really free and this mobile node is just follows just random waypoint mobility models, so this moves randomly. And one additional assumption is that key management and authentication are beyond the scope of this paper, so just concentrates on the idea of temporal constraint and minimizing the size of the transactions in the local blockchain. So the first approach is conventional blockchain. This is just the traditional way, so it maintains all the transactions in the network. So there is no regional or time constraint yet, and every single IoT nodes are connected together regardless of the region or the cell. So every single IoT node maintains the same chain data. So this is depicted in this figure, as you see. This mobility node and this static node, every single node has the same chain data in their own IoT node. And here is the second version of the blockchain. This is the improved temporal blockchain. So this replaced the chain data with aggregated version of it after certain time. So the genesis time information and temporal constraint are preset onto the IoT devices. And after a certain time period, this maintained chain data just changes into the aggregated version of the ordinary chain data. So this is generated via these two steps. The step one is that if blockchain lifetime meets the temporal constraint, just in the local blockchain, it select aggregator nodes through consensus mechanism. This consensus mechanism is just POS mechanism, but not the detailed version of the consensus mechanism is not explained in the paper. However, it just selects aggregator nodes through consensus mechanism in their local blockchain. So the selected node makes the aggregation block as this, and this one, and this one, and the aggregator node just broadcasts to other node in the network this aggregated version of the block. So after broadcasting this aggregated version of the block, then delete the remaining local copy of the blockchain, and just this aggregated version of the block remains in the IoT node. And this was the improved temporal blockchain. And here is the spatial blockchain. This is just the concept that breaking down a global blockchain into local blockchains. So this just maintains the local network per each cell. So any two local networks of two different cells are disjoint. So when the cells are different, then networks are disjoint. And the second feature of the spatial blockchain is a blockchain of a local blockchain in a cell is neither a parent nor a child of a block of another local blockchain in another set at a time instance. So this blockchain also have no common block when the cell is different. So this was the second feature of the spatial blockchain. And the final approach of the authors is the sensor chain. So sensor chain is the combination of improved temporal blockchain plus spatial blockchain. So region is divided into cells, and nodes form a local networks and maintain a local blockchain in each cell. So after temporal constraint, each local blockchain changes into aggregated version. This just contains the maximum or minimum kinds of aggregated version of the remaining local copy, and each IoT node holds the current cell ID and the copy of the local blockchain in IoT node. And the storage management is done with two ways. One is spatio-temporal, and the other is mobility-based storage management. These two storage management is both used in the sensor chain. And the first storage management step is the spatio-temporal blockchain management. There are two time constraint exist. One is temporal constraint, and the other is blockchain creation time constraint. So in summary, per block creation time constraint, each local blockchain network creates block, and per temporal constraint, it just creates the aggregated version of the local copy of the blockchain. So this assumes the temporal constraint is the same all along the cell, and each cell has different block creation time constraint. So here is the figure of the spatio-temporal blockchain management. I just explain step by step per blockchain creation time constraint and per temporal constraint. The first one is done with per block creation time constraint. Firstly, each local blockchain selects miner through consensus mechanism in each cell, and the selected miner gathers all the recent transactions and creates new block. And next, new block inserts into local blockchain, and the local blockchain is inserted newly in the local copy of the each local blockchain as this one, and this one. Blockchain network per cell just do actions per temporal constraint. So the step one is selecting aggregator through consensus mechanism in each cell. And then selected aggregator computes aggregation of its local blockchain and creates an aggregated block like this version. After that, just aggregator broadcasts aggregated block to other nodes in each local network. After IoT node receives the aggregated block, the nodes in the local network delete the copy of the existing local blockchain. So this is done per temporal constraint. And the next blockchain management way is the mobility-based blockchain management. This is done when a mobility node just passes from cell 1 to cell 2. So assume the mobile node moves from cell 1 to cell 2. Then just node compares current cell ID with new cell ID. Then this is done with two steps. Firstly, this mobile node deletes current copy of the local blockchain. In this case, this local copy would be deleted in this blockchain, in this mobile node. And then this mobile node downloads the copy of the new local blockchain from any peers in new cell. So after this mobile node just passes to the cell 2, then this mobile node downloads the copy of the new local blockchain as depicted in this figure, from any pairs in use cell 2. So randomly, these mobile nodes just download the local copy of the blockchain from this mobile node or this mobile node, and then this mobile node would uses the local copy of the blockchain in cell 2 in the case of mobility-based blockchain management. And this illustrated sensor chain just added to storage management, and this is just the way combining spatio-temporal with mobility-based blockchain management. And this figure just depicts two ways in time sequence. So firstly, this mobile node just goes from cell 1 to cell 2, and then this mobile node newly construct the network in cell 2 as depicted in this figure, and each local network just maintains the local copy of the blockchain. After that, after the temporal constraint, each aggregator node in each cell just makes aggregated version of the block, and then this aggregated version of the block remains in each cell, and each cell in the each IoT node in each cell just maintains this aggregated version of the local network. So this is the combination of spatio-temporal and the mobility-based blockchain management. And here is the experimental environment. It just uses syntactic data and ran simulation for 6 hours. And it simulates 4 approaches, which is stated as conventional, improved temporal, spatial, and sensor chain with above parameters. The area of the region is in 5 kilometer times 5 kilometer, and the number of each cell is just varies from 50 to 1000, and also the number of sensor nodes just changes from 1000 to 7000, and the speed of the nodes just randomly distributed from 0 to 50 km per hour, and the temporal constraint of the blockchain is just 1 hours, and the block creation time constraint is 10 minutes. And with this parameter, the authors just compare number of transactions stored on a single IoT sensor device. And here is the experimental result. This is the experiment in number of cells equals to 50, and number of sensors is just equals to 1000 in 5 kilometer times 5 kilometer region. This depicts that sensor chain approach just stores the less transaction than other approaches. A just depicts the number of stored transactions in a single IoT node, and figure B just depicts the comparison between conventional blockchain and the sensor chain. And figure C just compares the improved temporal blockchain with sensor chain, and the last figure D compares the number of stored transactions between spatial blockchain and sensor chain. And here is the further experimental result. Figure A just compares the spatial blockchain and the sensor chain blockchain in terms of the number of stored transactions in one single IoT node, and this depicts the number. This depicts the number of cells, and figure B just depicts the number of sensors, and compare the number of stored transactions between spatial blockchain and sensor chain blockchain. And here is my review of this paper. I think the consensus algorithm should be clarified in this sensor chain paper. They have stated that nodes use POS consensus algorithm, but they do not clarify the sequence of the consensus algorithm, so I cannot notify the consensus algorithm. So standard selecting miner and aggregator node is not clarified in the paper, so that I could not select miner and aggregator node because the standard is not clarified. And also, plus to the consensus algorithm, the incentive mechanism toward miner and aggregator nodes should be suggested in future for implementation of the sensor chain. And my second review toward this paper is that sensor chain applies in just specific scenario. I think sensor chain can be applied only in case of previous information is not necessary situation, and plus mathematically aggregated version of previous information is okay situation. So this would be just applied in real-time scenarios such as traffic control or environmental monitoring application. And here are the conclusion. Sensor chain is a lightweight scalable blockchain framework for resource constrained IoT sensor devices, combining temporal blockchain with spatial blockchain. This real implementation of sensor chain with real blockchain platform would be necessary to test the performance of the framework and verify the correctness of sensor chain. Thank you for listening.